Welcome to another episode of binomial expression, binomial theorem, binomial expansion. We are done with Pascal triangles binomial series. In this episode, episode 13, we'll be picking the combination aspect or the combination formula, which also give us the same answer if we are to expand a certain binomial expression. So let's just begin with some positive values. So let's say I have the usual a plus x exponent of n. The expansion of this making use of combination is n combination 0, a combination a exponent n minus 0, which is the evidence of the subscript there. But don't forget, n minus 0 will still give you n. So no need writing the 0. Then the next term, which is x, will also take the power as 0. Where in this case, a number raised to the power 0 is always 1. And 1 times c will remain c. So we don't write this. Then we add n combination 1. From 0, we are increasing the subscripts. So this will become a n minus 1, which is evidence in this one. That one is also evidence in the second term, x exponent 1, with the one we don't write. So I have the next term, 2an minus 2x exponent 2. I believe you are seeing the pattern that from 0, 1, 2, the next will be 3. The exponent is n minus 0, n minus 1, n minus 2. The exponent of the second term is also picking the same thing. Alright, let me just add plus n exponent n a n minus r x exponent r in some cases, and in some cases we use r. In this case, the number of terms we are going to generate in this expansion is always, let's say if this is the first, second, the n plus 1 give you the terms. Meaning if the n is, let's say 12, it means I'll be having 12 plus 1 making 13 different terms. They are different terms. 1, 2, 3 terms. Different by plus or minus. Alright. Then if I'm also looking for a specific term in the expansion, I can also say that if I'm using r as the term, so the r term will also be given by r minus 1 equals to n with the combination r, a, n minus r, then x exponent r. Don't forget the a and x are only in place of first term and second term. It could be any number, any value, any variable. Alright, so this is what, if I'm looking for a specific term or looking for a specific coefficient in a term, I go for this. Now, if I'm looking for the coefficient, so let's just say the coefficient is going to be n subscript 1 as 0, n subscript 1, that of 2, then n combination r. Don't forget, all these can also be written without the n because they are the same. So we just begin with C0, C1, C2, C3. Those are the coefficients of each of the term. Alright. We can also say that if I have this combination, how am I going to have effect this in calculation? It is given as n factorial divided by r factorial into bracket n minus r factorial. Right? In a simple term, if I have, let's say, 3 combination 2, if I want to find this, this simply means 3 factorial divided by 2 factorial, 3 minus 2 factorial. I believe the r is the subscript here, then the top superscript here is the n. Already we've learned the factorial under the previous episode that if I have n factorial, it is n times n minus 1, n minus 2 continuous, as in multiplying the integer or the number by successive numbers up to 1, from that integer positive down to 1. So this will mean 3 times 2 times 1 for 3 factorial divided by 2 factorial, 2 times 1. If you remove 2 from 3, you get 1 times what? 1 factorial, and that 1 factorial will also be 1. So now you can see 2 will cancel 2. 3 times 1 will be 3, divided by 1 will still give us 3. So it means in this calculation will give us 3. Alright, so let's see how we can manipulate this in questions. So 1 plus x exponent 7 is what we are asked to expand, where the 1 is taken in place of a. Then the x remain x. Your n will now be 7. Alright, now don't forget that 1 exponent, any number, still remain 1. So the moment your first term is 1, you are going to ignore the a in all the terms, because 1 exponent 9 is 1, exponent 4 is the same 1. So we ignore them. So now we are going to have this as the first term. 1 is ignored, so we go to plus. And okay, let's begin with 7, since the n is 7. 1, this one is gone, so we go for x, which is the evidence here, power 1. 7 combination 2x squared. 7 combination 3 x to the power 3. 7 combination 4 x to the power 4. Plus 7 combination 5 x to the power 5. 7 combination 6 x to the power 6. 7 combination 7 x to the power 7. Then when you get the last power equals to the n given to you in the question, then you stop and count and see whether it is n plus 1 10. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 terms, which is the 7 plus 1. Alright. So now we are going to have 7 combination 0, and that will give us 1. You can do that on the calculator, just like I expanded in the beginning. So 7 combination 0 will give us 1. So we have 1. This will be 7 combination 1. That will be 7 here. So 7x, 7 combination 2 will be 21 x squared. 7 combination 3, that will be 35 x to the power 3. 7 combination 4 will still be 35 x to the power 4. Then we go to 7 combination 5, that will be 21 exponent 5. 7 combination 6 will give us 7 to the power x to the power 6, plus the final one will be 7 combination 7, which I think will be 1. So 1 times x to the power 7. So this is what you are going to get if you are to expand using the combination approach. I believe you get the concept. If that is true, let's try 3 minus 2x. Let's expand this and share our answer in the comment section. Thank you for watching. Like and share. Bye-bye.